Hello everybody and welcome back to another episode of Math with Mr. Emond. In the last episode, I introduced linear inequalities to you and talked about solution regions and boundary lines, and we also did an example. Today what we're going to be doing is word problems that involve linear inequalities. Okay, last example of the day. Suppose that you're constructing a tabletop using aluminum and glass. The most that you can spend on materials is $50. Laminated safety glass costs, I'm going to start highlighting some things that I think are important. The most that you can spend is $50. So that has to be less than or equal to 50. Laminated safety glass costs $60 per meter squared, and aluminum costs $175 per foot. You can choose the dimensions of the table and the amount of each material used. Okay. Find all possible combinations of materials sufficient to make the tabletop. Excellent. Okay, let's get started. So here's the tabletop that we're trying to make. I'm going to actually just delete this so we can see it. There's the visual. Delete it. I want some working room. All right, let's make an equation. So we're going to have, well, we can't exceed spending $50. So we have to do less than or equal to $50. And then what do we have here? So aluminum costs $175 per foot. So $175 per foot, and we're going to put that as a Y. So what is Y? Y is feet of, well, aluminum, right? And we want $60 per meter squared of glass. So we'll just do 60x. And x, of course, is our meter squared of glass. All right, so our x-axis is going to be meter squared of glass, and our y-axis is going to be feet of aluminum. But just like in previous problems, we want to isolate y. So let's go ahead and do that. We'll start by kind of subtracting the 60x to the other side. So those are going to cancel out. And so you're going to have 1.75y is going to be less than or equal to negative 60x plus 50. And this is going to it's going to look a little bit funny here. So I'm just going to, okay, so we're going to divide by 1.75. Okay, divide by 1.75. And of course, the reason why we're doing that is to isolate y. So now we're going to have the equation y is going to be less than or equal to, I'm going to leave this one like that because my plan anyways is to plug this into a calculator just because it's going to be kind of a pain to sort out here. But I do want to know what my b value is, and I want like a good solid number, not a fraction. So let's do 50 divided by 1.75 and 28.5714. So plus 28.5714. So our slope is this, negative 60 divided by 1.75. Okay, so our slope is this, negative 60 over 1.75. And our b value is 28.5714. So, I mean, I could try to do this by hand, right? And say this was 30 and 28's like there. But if 28's there, then this is like negative 60. And like, it's just, yeah, it's kind of awkward, right? So I'm just going to make the executive decision here that I'm going to use my calculator. And so we're going to go and make a graph. And I'm going to erase this. I want y is going to be less than and equal to. And this is going to be negative 60 divided by 1.75 x plus 28.5714. Okay, so there's my graph. Now, I'm going to kind of show you a little trick. So obviously, does this look very good right now? No, it's kind of hard to figure out what's going on. So I'm going to hit menu. And I'm going to go to window, so 4, and I'm going to go to window settings. So this is going to show me you know, it's like setting up, do I want it to go from negative 10 to 10, etc., right? So I do, I think I want it to go just a little bit, maybe negative 1. And for my x value, I actually think just 1. So negative 1 to 1. And I'm going to explain why. It's because I saw earlier that the x-intercept didn't quite hit 1. And actually, because I'm doing this, I'm going to actually switch this to negative 0.1. So we're going to go back into window zoom, and I'm going to change this to negative 0.1. All right. Now my y max, I'll do y min first, 0.1 as well. So just below the x-axis is what I want my min value to be. And the reason why I'm doing this, x min of negative 0.1 and y min of negative 0.1, is so that it's basically going to be zooming in on quadrant 1. Now my y max, what is my b value? It's 28. So maybe we'll make this 30, okay? And what this should do is zoom in on my region, which it did. Perfect. So now I can see all of these points that fall within my solution region. Of course, nothing to the, you know what, let's, okay, we're going to window settings, y min, it's actually going to be, let's do negative 5. There we go. Okay, so we kind of zoomed in now, right? And the whole point was I want to see all the solutions that belong in this area here. Okay, so anything within quadrant 1, so to the right of my y-axis and above my x-axis, anything in this region is a possible solution, but it has to be below my line. And I would have known this because it's less than or equal to. And so let's kind of try to find a possible solution here. And, you know, you're going to kind of have to do some logical reasoning here. If I picked this point way up here, let's actually, so a cool function is this trace feature. And what this does is it kind of plops me on my graph here, and now I can move around and find all these points on the line. So if I look at this point right there, the y-intercept, or our b value, how many meters squared of glass do we have? 0. Well, can you make a table without actual glass tabletop? No, right? So that's that point. Although theoretically we can have 0 glass and 28.6 feet of aluminum, that's basically just aluminum sticks with no tabletop, so that doesn't work. And anything like over here, that's still, I mean, the glass is, there's so little glass. Your table's basically gonna look like this, right? You're gonna have a lot of aluminum with a little tiny glass tabletop. Like, that's not ideal, right? And again, like the further to this side I go, now I have very large glass, but no aluminum. And so that also, I mean, this is basically just a panel of glass with no aluminum, right? And that's obviously not going to work. And if I go just a little bit to the left here, so like there, now I have 0.715 meters squared of glass. So that's going to be smaller than this one, right? That's going to be something like that. But I still have only 4 feet of aluminum. So, I mean, there has to be 4 table legs. So those table legs are only a foot each. So this is very low to the ground, not ideal. Possible, right? This is a very low table, but let's try to pick something that actually kind of makes sense, which I would say is one of these kind of values over here, like maybe that one looks real nice. So it's 0.4 meters squared of glass, right? So you have a decent sized tabletop, and now we have 15 feet of table legs, and there's 4 legs, so that means each one is like between 3 to 4 feet, which seems, you know, kind of ideal, right? So now you have something 3 to 4 feet off the ground. You can stick your legs underneath there and sit down. So that, I would say, is a good solution right there. 0.4 and 14.9. And of course, you could have picked any number of other solutions by kind of zooming in and out here. And remember that any of these points also work, right? Like anything in this area also works. But the thing about those is you're definitely spending less than 50 bucks. Anything on your line here, you're spending exactly 50 bucks. And so I kind of would prefer to use those just because I'm getting the most table for my money. I'm getting $50 worth of table. And so it's going to be a good sized table. And as opposed to picking something over here that's going to be just really small, right? And yeah, it might only cost $5, but I can't even put a cup of coffee on there. So that's basically how you're going to approach this problem. All right, it's going to be your turn. I promise yours is a lot easier. You don't need a graphing calculator for it, okay? This is in your workbook. Go ahead and try it out. And when you're done, come back and check the solution. I'll see you soon. Hello, welcome back. Let's take a look at the solution. So, first step is to make an inequality. So you had 4 minutes on the cutting machine, so 4x, and you had 3 minutes on the for your soccer balls. So 4 minutes for your footballs, 3 minutes for your soccer balls, 4x plus 3y, and you cannot exceed 30 minutes. So then you want to isolate this. So you have y is less than or equal to negative 4/3 x plus 10. We know that our combinations, they kind of have to be whole numbers, don't they? Because you don't really want to have negative soccer balls or negative footballs. That doesn't make sense. And you also can't have 1.3 soccer balls. So they have to be whole numbers. Our b value is 10. Our m value is 4/3. That's going to let you draw this line. Now, this isn't quite the solution, right? Your solution is we need to be able to show our possibilities. And so this is where you're going to be doing something called stippling, right? Which is rather than shading, because shading is saying that everything within this region would be a solution. And that's not true, right? Only whole numbers are a solution. So for example, our x was footballs, right? So for example, we could make 3 footballs and 4 soccer balls, but we can't make 3.2 footballs, right? So that's where you're going to be stippling. This is what your graph should look like. Only quadrant 1, and we cannot exceed 30 minutes or less, so it's below your boundary there. All right, that's it for this lesson. Hope you enjoyed. Good luck on your practice. See you soon. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.